So we're going to use the difference quotient to compute the average value. And so we have S of 2 plus H minus S of 2 all over H. So really the main thing is finding out what S of 2 plus H looks like. That means we're putting 2 plus H into our function for t. So S of 2 plus H is going to be 64 minus 16 times, now here's where the 2 plus H comes in, putting in the 2 plus H for t, minus 1 squared, minus, now S of 2, which we've calculated before, is 48 all over H. And the S of 2, just plug 2 in for t and calculate. So now we got some simplifying to do. So first thing we're going to do, we have 64 minus 16. The 2 minus the 1 is going to give us a 1. So in here we have H plus 1, the quantity squared, minus 48 all over H. Now this is not H squared plus 1 squared. It needs to be FOILed out. It's H plus 1 times H plus 1. So we're going to have 64 minus 16 times H squared plus 2H plus 1 minus 48 all over H. Alright, we're going to distribute that 16, so we got 64 minus 16 H squared minus 32H minus 16 minus 48 all over H. Alright, now we're going to combine our like terms and see what we get. Look at this, I got 64 minus 16 is 48, minus 48 is 0, so those are going to cancel. So I get left with negative 16H squared minus 32H over H. So I'm going to factor in H out of that. So H times negative 16H minus 32 all over H. Those H's will cancel. And so, simplified, I get negative 16H minus 32. Now, we wanted to compare that to the average value between 1.5 and 2. Well, we found that earlier. It was negative 24 feet per second. Well, if we're going between 1.5 and 2, remember that H is that change in input. So that means I'm setting H to be, in this case, a negative 0.5, right? Because that's the distance between 1.5 and 2. So, finally, now you might be asking, why is it a negative 0.5? Well, if you look, I did S of 2 plus H minus S of 2. So to turn that into a 1.5, I would need an H of negative 0.5. So plugging that into here, we're going to get a positive 8 minus 32, or negative 24 feet per second. So that checks out. Now the other thing, remember what we were doing. We're letting the distance between our 2 points that we're finding the slope of get smaller and smaller to estimate that instantaneous rate of change. So we'd like H to be 0. Well, now we can put in 0 for H, and when H is 0, we get that the instantaneous velocity at 2 is equal to negative 32 feet per second. Now we had estimated that before, and now we found it's exactly negative 32 feet per second, which, remember, since it's negative, it means the height of the ball is decreasing.